Hi, welcome back to my YouTube channel. It's day 8 and we are going to learn embedded system for 30 days. And here we reach day 8 and the topic we are going to learn is advanced serial communication, which plays a major role in embedded systems. It is one of the very important topic for embedded systems. So today our class start with a question. Why does we use serial communication rather than parallel? So we are going to find out answer for this by the end of the video. So every embedded system uses microcontrollers. So it faces some problems. What are the problems which will be faced by using microcontrollers? Or it cannot show data visually. Generally, a microcontroller is a chip which do not have any display any output which will be shown as an output, and it cannot take keyboard data as input. If you imagine a computer and we can give the data directly using keyboard, but that's not possible in microcontrollers, and it has an heavy storage issues as microcontroller contains a small part of microprocessor and it only have just a little amount of memory storage. So these are the issues which we will face in the microcontrollers. So to overcome, there are some add-ons extensions, like it cannot use data visually. So we will be using a computer which displays the data to change or edit, and it cannot take the data through keyboard. So we'll be using monitoring softwares. Here the softwares which monitor the outcome and change as per the requirement, and the testing tools. So when we debug an error or a data, we need to test it. So we will be using an external tools for testing, that are testing tools. Let us get it through an real example. Assume a temperature sensor. It detects temperature. Assume a room and the temperature is like 32 degrees Celsius. This temperature would be sent to the microcontroller. This microcontroller analyzes the temperature as per the firmware requirement, and it's sent to the laptop monitoring, or which contains the software for running the firmware and detection. So the actual purpose of microcontroller units, it could help with monitoring sensor data lively and send commands to MCU and debug errors. And the next topic is serial communication. What serial communication does. Before getting into it, let us get two types of communication. There are two types of communication, one way and two way. One way communication is unidirectional. The data will be transferred from microcontroller unit to the computer. In two way, it's bidirectional. Microcontroller unit and computer will be communicating successively for better improvement and functionality of the firmware. So one-way communication will be used in debugging, monitoring the system and logging the data. These can be executed only once it's from MCU to computer. There is no feedback format that we could improve or change any data as per requirement. So only this data would be working only for once. So the alternative would be two-way communication. Two-way communication is used in controlling device. Assume an MCU sends a data of indetected and temperature and it's sent to the computer. The computer analyzes the temperature. If the temperature is high or low, it sends the feedback to the MCU. MCU rewrites the data, which helps in controlling the devices up there and parameter configuration. So we was detecting the temperature in this case. So we were configuring the parameters of temperature and industrial automation. So this case was practical example of automation. If there is any increase or decrease of value or in temperature rather than the required conditions, it would be communicated between microcontroller and computer and it could be automated using the perfect embedded and IoT systems. So we have been learning about sensors and sensors. So how does it really read the data? We'll be analyzing it now. So we will be learning it with an example. The first step would be logic. So example would be a potentiometer. It would be working with an voltage of 0 to 5 volts. As the same case, a sensor works on the basis of particular temperature we will be giving to make the sensor detect the surroundings or the capable conditions for the sensor. But here you might be thinking that MCU will understand only digital values, right? So we'll be using an ADC converter, analog to digital converter. Convert these values into digital values so that MCU can understand the values. Here, as we taken the example of potentiometer, which would be working on the in between 0 volts and 5 volts. The digital representation would be 0 volts could be written as 0 and 5 volts is written as 1023. So in a flow format, a sensor voltage, this voltage example, the voltages will be converted from analog to digital using the ADC converter, A to D converter. So the digital value will then transmitted using the serial transmitters. As we know, the serial communication is used in embedded systems. In this case, it would be sent bit by bit in serial transmission. So let us understand the practical Arduino code which will be written to get sensor value. So I have written the sensor detect the Arduino code for detecting the sensor values. I have written the code to explain it clearly line by line. And serial pin, we are going to give the sensor pin with the A0 analog pin of the Arduino Uno. And as the sensor value would be an integer, this line is written in serial value and void setup as usual. We would be opening the brackets. Serial dot begin 9600. This is written as the rate at which it communicates. This indicates it communicates at 9600 bits per second, and we are closing it in void loop. In void loop, we need to configure the sensor value. So it reads the value at the sensor pin which we have given here. Any output value we would read. So sensor is an analog type, analog read sensor pin. The output would be read in here, and we are printing the value of the sensor which it gives here, and the delay of 500. It means an 30 seconds of delay, and that's it. We are done with the program. After this, if we want, it can go through the same process again. So we have completed with how we write the code for sensor value in using Arduino, and now we'll understand how the serial monitors receive data. So with a flow diagram, user types a command. It is given to the serial monitor. Serial monitor sends the data to microcontroller. Microcontroller analyze the data using microprocessor which is inside it, the logical unit, and if any action need to be taken, it would be done here. So serial monitor examples would be, we can control speed of a motor, brightness of an LED. Let's see an Arduino code of serial monitor. So this is a code for the serial monitor in Arduino. Char command. We are writing a command for the character which we will be detecting at the end. Void setup. Serial begin. It's the speed rate at which it would be communicating 9600, and pin mode. Here we will be taking the output at the 13th pin and close it. We have opened the loop. So these are the main key conditions. If serial dot available is, these condition indicate if the the component values are present, then we need to include these steps. If not, that's the end. Assume the values are there. If available, it's available now. So command, it would be a variable for now. we will be reading the serial data, serial dot read. If another condition, if the command, the variable is equals to 1, that means the data is there. Then digital write, the 13th pin would be high. If we connect an LED, the LED would be glowing in this state. And if the variable, the command value is 0, the LED would be turned off. So that's the Arduino code for both sensor and serial monitor. Without further delay, let's get into other topic. So this is an interesting topic, serial buffer. Why do we use serial buffer? As we know, incoming data is temporarily stored here in the buffer. The data speeds of an MCU would be faster than the processing of MCU. So when this condition arrives, we might lose the data. So to prevent this, we will be using the serial buffer condition. Assume I send 10 character of data, but the MCU will process in the serial communication, which means it will be sending one after the other. If this fails, we will be losing the other data. So the other topic is serial data parsing. So parsing is extracting the information which is only required from the provided data. So we'll be giving us LED on. Here the LED is the command. We need to on it. On will be the action. This is a command and this is the action. We will be onning these LED. So the onning and offing is the action of it, and the command will be writing for an LED. It can be observed in IoT devices, diagnostics, and smart home. The other topic is serial monitoring and control. Sensor sends the data continuously. User also uses it simultaneously. Real life applications will be like development. When a product is ready, in the developing stage, it would be consisting multiple errors. So we would be continuously checking it and debugging the errors. So the development phase is debugging and testing. Is the product working fine? Is it giving the required output, or any flaws in it? The performance would be checked here in the testing field and field service. How it will be working, what would be the maintenance for it, and it at the end it will be a firmware. So the field service would be containing maintenance and firmware. So I hope you understand the serial communication topic of day 8. So that's it for the video. Let's meet in day 9. Till then, keep learning,